Second part of 4.6, fundamental theorem of algebra, is talking about finding polynomial functions given certain zeros. And a little reminder that if you had irrational zero, you would know that the conjugate is also a zero. And in this particular section, we're going to see that if you have a complex number, the conjugate of the complex number is also going to be a zero. Same idea as the radicals. And that's what this part is saying, and they give it a name, complex conjugates theorem. When do you use it? You use it on problems like this, finding out what the polynomial is given the zeros. So I can say f of x is equal to x plus 1. Again, the 0 would be negative 1, which matches that. X minus 4i and x plus 4i. There's the conjugate. So in this case, I don't have to regroup like I did before. I'm just going to go ahead and multiply the way it is because the middle term is going to cancel. X squared, let's see, negative 4i times x and positive 4i times x cancel, leaving you with 0. And then the last one is going to be a negative 4i plus 4 times 4i. That becomes a negative 16i squared, which is the same thing as negative 16 times negative 1, which is a positive 16. If you factor that, you would get what's above it. So I'm almost done. Now I just have to use a distribution, double distribution. So that becomes this, and multiplying the 1 through, and then putting it in order, x to the third plus x squared gives me that for my f of x. Now, if you had something like this, a lot more challenging of a problem, you would have to say x minus square root of 2, x plus square root of 2, x minus 1 minus 3i, x, getting a little bit close here, minus, and then the conjugate, which is 1 plus, sorry about this. Well, dang it. That's going to be x minus 1 plus 3i. That's what I'm trying to do over here. And then I wouldn't have you multiply that. That's simply going to be too long. But that's how you would set up that problem. It has a irrational 0 and a complex 0.